Here today. I am happy to be here in Leuven. Is this really Leuven or is this Heverlee? I don't know, but I'm happy to be in Belgium. I do a lot of presentations, and I don't do a lot of them in Belgium, so it's always nice to be on the home turf to some extent. So I'd like to welcome everyone here. I'm going to do the same thing in Dutch. Hallo, welkom iedereen. Leuk om hier nog eens in België te presenteren in het Nederlands, of op zijn minst mijn versie van het Nederlands. So let's switch back to English. This one is called Varnish for Drupal developers, and I gave it at a couple of Drupal events, and I hope it goes over well and we can connect well. Speaking of connecting, hi everyone to the brave souls who sit pretty much at the front. I come bearing gifts. It's easier for me to throw it to the first couple of rows than to the people in the back in the nosebleeds. I hope the weather's just as fine up there than it is over here. But I don't hold it against you. You have to sit where you're comfortable. But the ideas around connecting is I'd like to connect with you, and I'd like to make this a little bit of fun as well while we're doing this. And I typically do this through 3 distinct statements. I present a statement, and then we see whether or not the room agrees on it, and that will contribute to the vibe going forward. So, that being said, ladies and gentlemen in Leuven, are we ready for this? A little bit of a check? That's a lot better. I thought the first one would be weak, and then you have to do that obvious thing where do it again because it wasn't good enough. None of that. So, ladies and gentlemen in Leuven, do we agree that slow websites suck? Great, good, thank God. All right, number 2, do we agree that web performance is an essential part of the user experience? Yeah, of course, it's a competitive world, right? If you are slow, well, then people will go elsewhere. I also have a third statement, and in my opinion, it's slightly more controversial based on the reactions I get. So do we agree, ladies and gentlemen, that slow websites are just as bad as websites that are down? See? I see yes, I see. Any no's in here? Any naysayers in here? You could be honest, we're among friends. It depends. I love that. Are you a consultant, sir? It depends. Well, the consensus is meh, but here's the side effects of that. So if your website is slow or it is down, you will lose money. You will lose face, and you might even lose a little bit of Google PageRank. So that's what's going to happen. So how do we tackle this? How do we survive these problems? Well, a lot of people look at it from a very symptomatic point of view, and they say, well, it is slow, so it must be related to capacity, so let's throw some servers at the problem. Right? You can relate to that? We solve all performance problems by scaling out. I mean, AWS made themselves filthy rich off of it, right? And while this is not a dig at the cloud vendors, because it's you who spend the money on the scalability, but scalability by scaling out your systems or scaling them up isn't the worst thing in the world. When the house is on fire and firefighting needs to happen, of course, this is a way out. But in the long run, you're just throwing money at the problem. And as the famous poet Notorious B.I.G. once said, more money, more servers, more problems. So we've disqualified that as a potential solution. Now, I've done this presentation, or I use this image a lot of times. I know that I now need to pause for about 10 seconds. See? I was right. I paused for 10 seconds. Which brings me to the next part. Okay, we've disqualified just scaling out without thinking as a strategy. We've disqualified that. There are some use cases, temporary use cases. But the real way one could approach it is a very sensible way. Identify the slowest part of your systems. And our ecosystem, PHP, Drupal, and beyond, is pretty rich of tools that you can use for that. I mean, within Drupal, there's probably tools. You have Xdebug. You have a bunch of things. Figure out what is slowing you down, top down, bottom up, and optimize. Optimize, that could even mean find a new data center, or that could mean optimize the RAM in your system. And you could go all the way up, which Linux distribution, which patches are we doing, all the way up to JavaScript and optimizing images. Full stack, you'll find the value there. Now, the bad news about this is that while this works in the beginning, after a while, you will hit the point of diminishing returns, where the amount of money you pour into optimizing won't yield the same results after a while. Long story short, you can't optimize your way out of a scalability problem, right? So I have a third solution for you, and that's the theme of this presentation, and that is by using caching techniques. And caching, I love using this metaphor of boxes, is storing pre-computed results in boxes for later use. Back in the day, I always did that trick to people sitting in the front row. I'm going to do it to Sven. Sven, what's 2 times 2? It's 4. Did you compute that, or was that cached inside your brain through elementary school, right, all the way up, the TOEFLs, right, we had to learn those. That is a prime example of caching, and that is what I'm going to talk about today. So that being said, hi everyone, my name is Thijs. I'm happy to be in a location where I don't have to justify the pronunciation of my name, which is absolutely wonderful, Thijs. There's other Thijses here, I've seen them. We've empathized on doing or pronouncing and writing our name in an international context. Today is not the case. I hold the title of the technical evangelist at a company called Varnish Software. I know the title is quite a bit, the picture doesn't help. But long story short, I do a lot of outreach. I speak at a lot of events. I create video content, I write tutorials, documentation, I even write books. This is my first one, it's called Getting Started with Varnish Cache. Tremendous honor back in the day, being selected by O'Reilly to write this book. This is the little animal I got. No, I didn't get to choose. That's what I ended up with. But based on my facial expression, you can see that I'm no longer that excited about the book. It's an old one. So I wrote a new one called Varnish 6 by Example. I have a free copy of the book here. It's a mammoth of a book, 778 pages. If you ask me what I did during the COVID lockdowns, they were long. This is the output. A lot of the stuff I'm going to talk about is in this book. For sure, I'm not taking this book back home. So it's going to stay here, and someone will grab this, or the people, the cleanup crew, are going to throw this in the bin. That is how that's going to work. If you're not a book person, but you're a socks person, I come bearing gifts. I have 4 pairs of socks. I think the distance from the front rows is shorter, so it'll benefit them. I've heard that socks are the new t-shirts. Take it or leave it. There we go. So who's heard of Varnish software? By a show of hands, wow, it's great. I'm used to going to rooms where that number is a lot less. In case you wonder, in case you didn't raise your hand, we're a company that builds software-defined web acceleration and content delivery solutions with a very strong emphasis on software-defined. That means you can install it wherever you want. You can do that with a hosting company or on your own servers on-prem. You can bootstrap us in the cloud. We have official machine images in the various marketplaces on AWS and on Google and on Azure and on Oracle. You can find it there, pre-installed, run it, get started. Yes, we have Docker images, use them. And yes, you can orchestrate them using our official Helm charts. Most people know us as a company that does web acceleration or API acceleration, but I also came here to tell you that we accelerate all of the things, everything. And it would surprise you. Like, we're in a Drupal context here, so yeah, I know I spent a fair share of hours turning that one in Illustrator into a bunny, our signature bunny. But we accelerate a lot of things. Some of our biggest clients are streaming providers and telecom players who want video acceleration. Video these days is also HTTP. We have automotive companies who do their software updates with Varnish. We have build pipelines, Docker image acceleration, you name it. I'm not going to talk about AI, but AI is also a use case where a lot of data is moved and caching. Makes sense. But I do admit, besides what I'm telling you here about something that fits more into a commercial strategy, I do need to admit and acknowledge that most people know us as the company behind the very popular open source project. It's a fact. And we are well integrated into Drupal and have been since a very, very long time. If you go to drupal.org, there is a page about Varnish. It links to a tutorial I maintain about how to spin Varnish up for Drupal. I'm going to work on it, and that's my question or my suggestion to you. If you see something on the tutorial that is linked there that you don't like, or if you think this page needs an update, reach out to me. I'm easy to find at ThijsFeryn on all the platforms, and I'll be more than willing to make it easier, make it more turnkey, and lower the barrier of entry. So for those of you who aren't familiar with how a reverse caching proxy like Varnish works, here's a little diagram, because caches all over the place, right, in IT. There's, like, a lot of people use Redis or Memcached or whatever caching system that their operating system has. We are a reverse caching proxy, which means we position ourselves right in front of your Drupal application. Sometimes hosted on the same box, sometimes or mostly on separate machines. We take over port 80 and 443 of your domain. We are the point of entry. And we actually protect, shield your Drupal application from a variety of things, from like a sheer onslaught of traffic, like number of requests, bandwidth, but also we have a sort of a prominent role on the edge to do certain personalizations or security-related tasks, if you will. Purely from a shielding perspective, we would consider that a quality of service benefit. We improve the quality of service of your Drupal system. But if you position your caches very strategically close to your end users, you could lower the latency as well. The distance between the user and the Varnish server, that gap could be closed, and that's a quality of experience benefit. So that being said, there's a lot of caches out there. This one, the way we do it, leverages the HTTP protocol. And the HTTP protocol, whether you like it or not, whether you know it or not, has built-in caching mechanisms that we respect. These are conventions. We didn't invent them. A lot of people in the caching and acceleration space leverage headers like this. We've all seen this, right? This shouldn't look like an alien thing. This allows you as an application developer, or Drupal as an application, to control the behavior of the cache solely by specifying headers like this. And the values I use come directly from Drupal. So Drupal could say max age 86,400 public. And that pretty much tells the cache that this is public data, so you can cache it, the browser can cache it, and both of you can cache it for a day, which is the equivalent of 86,400 seconds. Now, of course, there are pages that are uncacheable, that depend highly on state. Well, Drupal will issue these no cache must revalidate private headers. And we comply to those. It's pretty easy. And it's very easy for us to do this in a static context. Oh, it's a static HTML file. We'll put that in the cache. Imagery, no problem. CSS, JavaScript, it's pretty much our bread and butter. It does get a little bit sticky and more difficult when cookies are involved. Here's a statement up there. Varnish does not cache when cookies are used. Quite of a controversial one, because who knows websites these days that don't use cookies? Like modern websites. They all use cookies. So does that mean Varnish can't be used in the real world? Of course not. But that means we have to be more opinionated. Because that also applies to authorization data. Like when an authorization header pops up, just like a cookie, we assume that the content is for your eyes only. And storing it in the cache verbatim is a big problem. There's a lot of war stories from the trenches, right? People caching things too aggressively. Like this famous story of this tax office that was too heavy on the caching, and that one poor bastard's tax returns were stored in the cache, and everyone saw it. On a personal level, there was a big Belgian festival when I worked at a Belgian hosting company back in the day that was doing ticket sales, and I was in charge of setting up the Varnish. Slightly too aggressive, and everyone saw, "Hi, Bob," in the top banner, and what Bob ordered. A bit of a problem. So we have to be very careful and mindful when it comes to caching when state is involved. And the way we do this, that makes us quite unique, is in Varnish, there's a built-in programming language called the Varnish Configuration Language, or VCL. It is not a top-down programming language. It is a language that hooks into a finite state machine. This is the state machine. This is the finite state machine. You can hook into it and plug into the various boxes that you see. Every box represents a state in the execution flow, and they're named accordingly. It looks maybe a bit abstract, but at the top left side, you start at start. It's not too much to ask for me to expect that you can read a flowchart, right? Is that the appropriate level here in the room, can I assume? Well, in that case, you start at the beginning, and you go to VCL Rec V, which is short for receive. So what happens there is you receive an HTTP request, and then you deem it cacheable or not cacheable based on a bunch of decisions. When it turns out that it's cacheable, you will go to VCL hash, where you will create the caching hash. And the caching hash is composed of the URL and the host header. And those two together form the full URL. We hash that, look it up in the cache, and then you can have a hit, a miss, a pass, or a bunch of other things. Let's follow the scenario of a cache miss. A cache miss is not bad. A cache hit is a hit that hasn't happened yet, but the next time it will. So we follow the blue path to VCL miss, which will take us to this big gray box. I would call it the big gray box of doom, but you do want to avoid ending up in there every single time, because it implies that you connect to Drupal to fetch some sort of a result. So you go to VCL backend fetch, which will copy over the original HTTP request, maybe perform some alterations. And when the response comes back, you're in VCL backend response, where you probably have made a decision on the cacheability on the way back. You get a TTL either from your backend or VCL, you store it and you deliver it. That's scenario one. So the next time you do all that, you enter VCL receive again, you look it up in the cache, hit, no problem, deliver it. So follow the way down and deliver it. And you can hook into every single box and extend the behavior. Because it's not a top-down programming language, we have some assumed behavior, some built-in VCL behavior that follows the conventions and is very conservative. So I told you about cookies. The standard behavior is if we see a request with a cookie header in it, we don't cache out of the box. When we see a response come in with a set cookie header in it, we don't store it in the cache because we know that it will change the state. A set cookie header is a state changer. So all of that. So let me show you some VCL. This is an extension of the built-in VCL, and it comes from the Drupal template. So in the beginning, we defined the backend. I named it drupal.example.com on port 80, and we've defined an ACL, an access control list. It contains IP addresses, subnets, and host names of systems that are allowed to invalidate the cache. And that will typically be the host names of your Drupal system. And then you define VCL receive, which extends the receiving behavior. We already set some ESI-related stuff, and we clean up the URL by trimming off trailing question marks. So if you have a trailing question mark in your URL, you had the intention of setting a query string parameter, but you didn't, because there's nothing following it. And while it doesn't have an impact on the content that is represented, the page output will be the same, it will change the hash, because the URL is different. So we need to clean it up, we need to sanitize it by trimming it off. If port numbers end up in the host header, same deal. Content is the same, but the caching key might change. And don't underestimate the fact, the bottom line, that you need to alphabetically sort query string parameters. If you put them in a different order, page output will be the same, but cache key will differ and you'll have a cache miss. So one aspect of it is the cleanup. Also security-related stuff, we learned not to trust the user, so anything we can do there, we do. But then we also need to determine cacheability. And then you have some URL patterns that match regular expressions of things we know we don't want to cache. So what we do is do a return pass. So we override the standard behavior. And if I take you back to the diagram, you're in VCL receive, you go to hash, you pass, it's a red line. It's the red line that you follow. So this will always bypass the cache every single time because we know it's not cacheable. So that's how that works. And then we dive into the cookies. Instead of saying, as soon as there's a cookie, we will not cache, we'll be very deliberate about the cookie behavior. And I apologize for the ugly regular expressions because that's the way historically it was done. There are better ways, of course, but let's dive through it. The idea is if there is a cookie request header represented by rec.http.cookie, then we need to check what cookies are there. And we know that Drupal only needs the session cookie, which is represented by that regular expression, ses or sses, and then a bunch of alphanumerical characters, or a no cache cookie. So we want to keep that one. All the rest is gone. So every tracking cookie from Google Analytics or from HubSpot or all the other tools you use are not relevant to Varnish and are not relevant to Drupal. They are processed right there in JavaScript. So trim them off, and if at the end of the day, after doing all the finds and replaces, you have a collection of white space characters, then there's no cookies left. You can remove the cookie header and carry on. Under all other circumstances, we assume that the session cookie or the no cache cookie are still there, and then we bypass the cache. And that will amplify your hit rate dramatically. This will make sure that the majority of the pages that don't require a session cookie are cacheable. And that's just one of the ways. Another thing you can do is take away all that ugly regular expression mumbo-jumbo and replace it with a cleaner interface. This is also, if you have a relatively recent version of Varnish, there is a cookie module in there that you can import. And you have a parse function, or parse method, that takes in the cookie, and then you could say, only keep the cookies that match this regular expression, write the string back, and you're done. It's a lot cleaner, a lot easier to understand. Now, this is not a VCL presentation. I want to do a little bit tippy-toeing, dip our feet into the huge ocean that is VCL. But I do want to say, if you feel a bit uncomfortable about that, that it's part of a template. You don't really need to write it yourself unless you really want to. And we wrote a tutorial, that's the tutorial that is linked out there, with ways how to configure it. And I know most of you, like 99.999% of people in the room are a lot more experienced with Drupal than I am, but I'm still going to give you a get started from my perspective. Feel free to disagree or to interject, but this is primarily about the caching aspect. So in order to get started, I'm assuming Drupal is already installed. But in the configuration, there is a caching section where you can enable the caching policy and choose how long you want to cache it. I would recommend that you do that. And when it's set, maybe to a day, then all of a sudden it will no longer do a no cache, no store, but it will start emitting this, max H 86,400 public. That's what's going to happen, and you need to enable that. But there's only one thing more dangerous than not caching enough. That's caching for too long. It's a gigantic problem. You need to purge the cache. You need to flush the cache, empty the cache. Things can get clogged up quite quickly. I think media websites are the perfect example. You put a level of caching out there to give a good quality of experience and a quality of service to ensure that when you have breaking news and thousands of people come on your website, that the website doesn't go down. The other end of the spectrum is no one will see the breaking news because the caches are caching an older version. So you need to hook that into your Drupal to ensure that when there is an update of the content, that content finds itself updated. I'm not talking about completely flushing the cache. I'm talking about deliberately and granularly picking objects that match certain tags, that's how Drupal does it, and fix it. And in order to do that, I would recommend installing this module, the purge HTTP module. It has some dependencies that it automatically loads, and it leverages something really interesting in Drupal. It is tag-based cache invalidation. Now, I remember the olden days. I used to work at a Belgian hosting company for 15 years, and cache invalidations historically in Drupal was kind of hard. I'm looking at the old schoolers here in the room who can relate to the Drupal 5 and 6 days. Things weren't that good. Because the difficult thing is, and WordPress, I'm sorry for using the word in this context, but WordPress did it based on the URLs, because their structure was so simple. In WordPress, you have a post, you have a page, you have a feed, you have a category, what have you. It's very limited. So when something changes in there, you know what URLs are impacted, and you do it based on URLs. To Drupal's credit, in Drupal, you can do a lot more complicated content management workflows, which means that a widget with a piece of content could end up on 1,000 different pages. If the content of that widget changes, good luck keeping track of all the URLs that you need to invalidate. So what Drupal decided to do, and what I'm going to show you here, is use a response header called purge cache tags, which is part of that module, and will emit a bunch of tags. The one that I care about is that this is node 1. So when node 1 gets affected, whether it's just a page or used in different pieces, we know that this needs to be invalidated. Drupal supports it, and we, to some extent, support it as well. I'm going to repeat the word to some extent, and I'll get back to that. So the way you would do that, again, in that module, is to configure a purger. In the first tab, request, you will say where Varnish is hosted, so which port, which host name, maybe some, if you put an authorization layer on there, maybe an authorization token, and this and that. But it's important to spot the purge cache tags header and use this pre-made syntax that this module offers you. It will include the syntax of the tag invalidation and will act accordingly. This means that you can then use drush, if you want to invalidate specific parts. So I'm talking about this syntax. It could be a tag, it could be everything, it could be a URL, it could be a path. All of this is configurable with the p-invalidate command, if you want to do that explicitly. Of course, you can also use the cron for it. If the cron runs and there's things in queue that need to be invalidated, you can do that. But there's also a part in it where you could just press save. If you press save wherever in the UI, it will automatically do that for you. And I think that's the easiest bit. Maybe if you want to delay the invalidations, you can take them as part of a queue that you need to process, but in your day-to-day, when you update a page, you will invalidate that. But here's where the story changes. As a long-time user of Varnish, I've noticed some limitations in that respect. There's some common obstacles, and they're not related to Drupal. They're more at our end of the spectrum, problems in Varnish. I wouldn't call them problems, I would rather call them challenges. There's no native TLS handling in Varnish, which has always been problematic. And while we are the company behind the open source project, we don't have final say. Which is kind of nice, right? That a corporate entity can't impose its will on an open source project. That's very much the case with us. We don't control the agenda of the open source roadmap. We do contribute to it, we finance part of it, we assign developer time to it, but the project lead ultimately has final say, and that's not us. And the project lead, to this day, hasn't found an implementation of TLS that he finds good enough to implement into Varnish. That's the historic reason. So it's a bit of an issue that you have to terminate TLS elsewhere. Also, backends are static. So in the modern world of orchestration, scalability, DNS resolution happens at compile time. So when something changes, Varnish doesn't spot it. Cache invalidation doesn't have soft purging, and it doesn't have native tag-based cache invalidation. We can handle the tags, but not in a native way. Another problem is, at runtime, when you have a really busy site, controlling the memory management and the storage can get tricky. And finally, a lot of people struggle with VCL. It's not a difficult language, but it's a bit out there, and you have to learn it and master it. I spent some time learning it. It's still at the heart of everything we do, despite us developing an edge compute suite that does more things in JavaScript or other languages. We still really believe in VCL. And while we are trying to influence the open source, it doesn't happen at the pace that we always want to, so that's where we came up with some solutions. It is part of a commercial offering, but what we've done is try to lower the barrier of entry. So the only thing, I'm not going to sell you anything, I'm an evangelist, I'm not a salesperson. The only thing I'm going to put your attention on is that we now have a pro version of Varnish, which is not an enterprise version, because we've come to realize over the years that not all developers work in entities that qualify themselves as enterprise. It was a lot of people got scared away by that term. So we have a pro offering that you can also find in the AWS marketplace, where for relatively cheap you can try some really advanced features, such as native TLS. We've decided, and it should have been there all along, that Varnish deserves native TLS. So we do it end-to-end now, where you can have TLS natively in Varnish by registering a listening port on 443, which is the native TLS port. Now, of course, in open source Varnish, you can throw that in as well, and you would typically do that to accept offloaded TLS connections. But this can be done natively, and you can register TLS certificates with added syntax in the Varnish ADM command. So when you want to manage Varnish, you can load TLS certificates, and you can also reload these certificates without emptying the cache when push comes to shove, when certificates expire, and so on and so forth. So what I would recommend that you do is have a script, a little file, a config file, where you put some of these commands in to dynamically load the certificate, and tie them into the runtime process with the -i uppercase runtime parameter. That will link this and will ensure that these commands get executed every time Varnish starts, which is what you'd expect. Now that's just one side of the coin. The other side is that you need backend TLS as well. So we introduced extra language in there, SSL equals 1 or 0, doing the SNI, the verification of the peer and the host. The last three are always on. I just put them on there to show you that you can disable them. Maybe you have self-signed certificates you want to use, maybe you don't want to use SNI. That's the TLS bit, check. Feature number 2 I want to talk about is the memory governor. I love that name, the memory governor, and I decided to play around in Illustrator again and created this image for you. And then it's pretty much self-explanatory. The memory governor governs the memory, it manages the memory. And what it does is it limits the size of the memory in the Varnish process rather than the size of the cache. And it's built on a very common misconception in the world of Varnish and the world of caching. So this is a standard option in the Varnish D process, -s malloc 8 gigabytes. And one would think, right, that now Varnish will consume 8 gigabytes. Well, wrong. It will assign 8 gigabytes to the cache, but it needs memory as well to handle incoming requests. If you have a sudden traffic spike, as I would hope when content goes viral, or you have breaking news, or you do a marketing release, then that 8 gigabytes might not be enough. So then it's up to you to figure out how much memory do I really need to add to make things stable. And the way we've tackled that is by not using malloc, but MSE, which is our storage engine that has the memory governor in there. And what it does is it keeps a constant memory footprint. So if you look at the 2 examples that I have here, when you have low traffic patterns on a 100 gigabyte server, for example, you would have maybe, these are all hypothetical numbers, right? 89 gigabytes for the cache, then a little bit for memory accounting, depending on the size of the objects in the cache, and maybe some runtime requirements for request handling. Of course, if you have that sudden spike of traffic, instead of running out of memory, we will dynamically reduce the size of the cache to ensure that the other bits and parts, notably the accounting for the number of objects and the amount of memory you need to handle all those threads, that those get more. And they get resized automatically. And it's as simple as just doing S minus MSE, and it will assign 80% of your server's memory to Varnish. 80% out of the box. You can change that with the memory target runtime parameter and set it to another percentage or another absolute value. And that's how you solve that problem. It's an operational problem. A problem that is very relevant to the Drupal world, and I also noticed that it resonates really, really well in the Magento world, is tag-based cache invalidation with soft purging. So you remember these? These are the tags that the module emits and stores. So the purge cache tags header gets stored in the cache along with its value, so all these tags. And at the invalidation level, we can match those tags. So this is the current implementation. Again, a little bit of VCL that focuses on the cache invalidation. Specifically this, the ban function. And the ban function is a VCL function that will add a ban expression to the so-called ban list. This gets evaluated. So in this case, we're matching the cached object's purge cache tags header, which you've seen earlier, we store it in the cache, and match a value to it. So when Drupal needs to invalidate maybe node:1, it sends that value over to the tag, we assign it, we match it, and it's a simple regex expression. I have some examples here. So let's say, hypothetically, that your object that you're storing in the cache only has the node:1 tag. Well, we store it. And then when Drupal does the invalidation, the left-hand box does a ban request. So the way you configure your invalidation module is by saying, hey, you can use a specific request method to stipulate that you're doing cache invalidation. In the RESTful world, we know that a get and a head and a post and a put and a delete and all of those are official request methods. In the world of caching, we either use purge or ban. And Drupal tends more to use the ban request method. So it sends a request method, ban, for the homepage for Drupal.test, for example, to the system, and it assigns that node:1 tag for it to say to Varnish, please remove node:1 from the cache. And we do so. Or you can assign everything that has node list in it. So what will end up happening, if you look at the bottom side, is these expressions will end up on the ban list. And what we're doing to match them is pure regular expressions. If the header contains node.1, match it. Here's what the problem is underneath. The more objects you have, the more expensive it will be to match it. Let's say you have 1 million objects in the cache and 100 cache invalidation rules on the ban list. That's 100 million expressions that need to be invalidated. So it doesn't scale that well. For small and medium-sized websites, no problem. But at a certain scale, it will start hurting you. And the way we've solved that is by adding an extra module called ykey. And before we store the object in the cache, we will inspect a certain header. Now we mentioned that you need to inspect the purge cache tags header. And you can have multiple tags, and we'll separate them by spaces. So that means we will index the values of that header and treat them as first-class citizens, as actual tags, which are easier to invalidate, a lot more performant. I'm also adding an arbitrary everything key. Every object has that. So if you invalidate the everything key, everything is gone. And if I move back to, do I have the command still? I'm going to go back, way back. Sorry for that, that wasn't planned. The second line, p invalidate everything. You can define an everything invalidator, and it just triggers that tag, and everything is gone. So there are some challenges with that, but if you look at the output of my logs, it will spot the block view, node view, and node:1 tags, and it will index them separately. So we can match multiple tags at the same time, and that means at the Drupal level, instead of having a regular purger, we can have a bundled purger where multiple tags are matched at the same time. And the syntax slightly differs. So if you do a bundled purger, your expression is a bit different. So invalidation, separated comma, because there's comma separated tags. You define it as such, and then you can hook in. And the only thing we need to do is just change that little piece of code to make it happen. And the end result of all of this, and I like showing logs because they show the real-world view, is, again, we intercept a request. This is the Varnish logs for that single transaction. We receive a request with a ban request method for the homepage. It has the Drupal.test host header, and the request header contains purge cache tags with the tags we want to match. We receive the request. We notice that the IP address matches the access control list and is allowed to perform the invalidation. And then the indexing kicks in and says, well, we spot node:1 and node list page, we'll match those. We'll hash it, look it up, and we will return the fact that a single object was affected by this. There was only one object in the cache that matches these tags. And that's how efficient you can do that. It's no longer matching things on the banned list, doing permutations on all the objects of the cache. This is a lot more scalable. But I didn't give you the real value. The real value lies in that little argument called true that allows you to do soft purging. Anyone familiar with soft purging here? I see a very brave person in the back raising their, yes, I can still see you out there. Soft purging, well, I'll give you hard purging first. Hard purging means identify objects that need to be out of the cache and remove them instantly, which is good because there's no conflict of data. The data is consistent. The downside is if you remove a whole range of objects from the cache, requests to these objects are now exposing your Drupal directly. And if there's a lot of them, that could create serious problems. Soft purging, rather than removing objects from the cache immediately, implies that you mark them as invalidated and you do an asynchronous fetch later on. So it's a matter of eventual consistency. And all of that leverages a wonderful feature in Varnish that is called the grace mode. And we have to do a little bit of, I wouldn't call it math, a little bit of logic here. This is the comparison, this is the equation that we need to follow. So if you store something in the cache, the total object lifetime is not just the TTL. It is the sum of the TTL, the grace value, and the keep value. Now TTL, you probably know that one, right? That's the 86,400 seconds that was set initially either in VCL or to your cache control header. When that expires, when the TTL hits 0, your object is in need of revalidation. It's now officially stale. And revalidation means someone needs to connect back to Drupal and get the latest version. But luckily, there's grace as well. And grace is our implementation of HTTP standard called stale while revalidate. It defaults to 10 seconds, but you can override it to a much bigger number. And as long as there's grace time left, even if the TTL hits 0 or goes below 0, we will keep serving the old object for the sake of the quality of experience while doing an asynchronous revalidation and getting the new one. Keep is not really relevant in that case. But what soft purging does is it just sets the TTL to 0. It doesn't remove the object from the cache. It just sets it to 0. And that means the next visitor will get the result immediately because there will be some grace time left, and we'll update the cache. Now, how much grace time, you ask? You could set it to 3 days by doing this. Just set it to that value. And again, some logs to prove the situation. So after having done the invalidation, we receive a request for the /test page. We create the hash using the request URL in the host header, as I've shown you in the diagram earlier in the presentation. We look it up, and boy, are we happy we have a cache hit. Look at this, hit. Great, I marked it in red. But what you also see in the second field is that the remaining TTL is minus 4.77 seconds. The TTL is a moving number. That means that 4.77 seconds ago, we did a soft purge on it. And typically, that should be a cache miss, but it is a hit because there's 259,200 seconds of grace time left. It's the equivalent of 3 days. So instead of doing just a miss, we do a hit, but at the same time, we do a background fetch. And that's how soft purges work. And I notice specifically in the Magento world, and I hear some good feedback from the Drupal world as well, that is a game changer sometimes when you, if you have certain categorizing tags that affect a lot of objects, that could result in a lot of problems. And this tackles those problems to some extent. It's up to you to set the grace value how long you want. You have to identify on a per object or per page level what the tolerated staleness of the content is. I was dealing with a potential client who was a trader and was trading in gold, and he wanted those gold prices to be up to date. There's no tolerated staleness there. They prefer a cache miss and a hard invalidation over old data. It's up to you. And you can even control it yourself in the cache control header. There's a directive called stale while revalidate, and you can set that to a number. You can write some code in Drupal that does that, and we will respect it. That way, we don't need to set the grace value that you have here, and you can do it yourself. We're almost there. I know I have 50 minutes. We're 30 minutes, 38 minutes in. I'm not going to take all your time. I mean, we could take a break afterwards, have a chat. I won't do Q&A either. I don't like Q&A. The reason I don't like Q&A is because most people asking the questions have this hyper-personalized question that 99% of the room doesn't care about. That doesn't mean you can't ask questions. If you have questions, just approach me. I'll be happy to answer. I'll stick around until 5 o'clock, I guess. So at least I'll save you some time there. But the last feature, or one of the last features I want to talk about, is dynamic backends. So in Varnish, DNS resolution happens at compile time. Compile time means compiling the VCL file before it gets turned into C code, and that C code gets compiled into machine code, making VCL very fast, but with that limitation that the DNS resolution only happens once. So when things would change at runtime, and if you use DNS-based load balancing or DNS-based service discovery, you're in a whole lot of trouble. So what we've developed is a set of extra modules that allow you to control the behavior of DNS. So let me highlight a couple of lines of code here. We have a module called active DNS in which you can specify a host name, and you can also position the port in there. And then in this case, you can abide DNS TTLs. I mean, the DNS protocol has TTLs in it as well. You can cache DNS resolution for an hour. Without DNS caching, the internet will fall over. But we can choose to ignore that. And we're doing that here. We do a set rule called force, and we force it to 5 seconds. So every 5 seconds, new DNS resolution happens, and we will spot any changes. And we will take the values that we get from the DNS resolution, along with the port, and push them into a backend template called default, which you can see here, or a health check. We can pre-populate that. And then, in the end, we can listen, we can subscribe to that active DNS resolution, which happens in the background. So every time we do a fetch, we get the latest value. So we do DNS-based load balancing, and if a DNS record, could be an A record, could be an SRV record or others, returns more than one result, more than one IP address, we'll just load balance over it. So let's say you create a DNS record with 2 IP addresses in it, which pretty much means 2 DNS records with the same name. We could do hash distribution to do consistent hashing. We can do fallback. We can do random. We can do all of that. And in the end, every time you need to call the Drupal backend, we will fetch the latest version and do dynamic backends. Giving you the opportunity, like if you would use the dig command on Linux, and you have drupalexample.com, maybe you'll have 2 IP addresses. Well, by doing that, at the top, you have DNS-based load balancing. But here's another advantage. We support SRV records. SRV records are interesting. In their notation alone, it's a service, a protocol, and a host name. So our Drupal service could be _drupal._tcp.example.com and would yield the following results. Not only host names or IP addresses, but also the port number, the priority, and the weight. So all of a sudden, you can decide on load balancing and on fallback and on port association purely at the DNS level. You're not married to your backend port. You're not married to the order of execution in your VCL. You can alter it on the fly. And that plays well, like, who deploys Drupal and Kubernetes here? Are there? Quite a few. Interesting. Well, your service in Kubernetes has a name. Maybe it's called Drupal. Maybe it lives in the default namespace, while DNS-based load balancing would yield this backend that you put in VCL, Drupal.default svc cluster local. But you can also leverage an SRV record that is part of Kubernetes' DNS system and use the named port. So you can do _HTTPS TCP Drupal default svc cluster local. And that way, we don't need to care about the port anymore or the weights or whatever. You can configure that. Now, all that stuff, you don't have to figure that out yourself. We can give you an optimized VCL file for it, where all these features come in handy. And that's it. That's pretty much it. We package it as Varnish Pro. You can get it as Varnish Enterprise. We are doing some extra stuff in there as well that is deliberately targeted at the Drupal and Magento community. So if you're interested, talk to me about that. I thank you for being here. You have options. You can either choose to be in the other room, here, or in the contribution room, and you took 50-odd minutes out of your schedule to be here with me. I appreciate that. Thank you very much, everyone.